Jai Hind. My name is Niharika Tripathi, working as assistant professor in CSA department at AKGEC Engineering College, Ghaziabad. Today, I will be discussing about the topic a priori algorithm and clustering techniques. It is in unit 4 of subject data analytics and visualization, KDS 501. So today, I will first topic is a priori algorithm. What is a priori algorithm? So what basically a priori algorithm is an algorithm that is used to find the frequent item sets in a data set. So what are frequent item sets? Suppose we are going for a shopping website and like we purchase our groceries. Usually we the item sets which are frequently bought together. For example, milk and bread. They are the mostly bought items in a data set. So these are the frequently used. So we categorize the frequently used data items in a data set, and then we generate some association rules. So the association rules are basically generated using the a priori algorithm. So what is this? This algorithm uses frequent item sets to generate association rules, and it is designed to work on the databases that contains transactions. It is an iterative process for finding the frequent item sets. So as I discussed, if we are going to calculate the frequent item sets, the products or the data sets which are brought together. So this algorithm was given by R. Agarwal and Shrikant in the year 1994. So it is mostly used for market-based analysis and helps to find those products that can be bought together. So the product items which can be bought together, we calculate this using a priori algorithm. It can be used in healthcare field to find the drug reactions for the patients, like for which kind of patient, which allergic patient the drug which drug will work. So we use this algorithm. So what is the working? We will discuss this algorithm using an example. So what is the basic working? So in the first step, we find out the support of item set. So minimum support count, or we can say a minimum value, is given to identify the data sets. So we find, first of all, we calculate the minimum support of the item sets in the database and select the minimum support. So what is the minimum support? Suppose there are values 3, 4, 5, 6, 7. We assume that if any value that is having less than 3 will be discarded. So in the values 3, 4, 5, 6, 7, all the values will be taken because they are none of the values less than 3. So in the first step, we count the support item sets. Now take all the supports in the transaction with higher support value than the minimum or the selected support value. Then we find the rules, and then we sort the rules as the decreasing order of the left. Now let us solve this using an example. And now next is the items. What are the items we are having? So suppose this the items ID is T1, T2, T3, T4 and T5 and T6. Now next is what are the item sets in this transaction ID? So I'll write here ID and the item sets. So the transactions are T1, T2, T3, T4, T5 and T6. The item sets are hot dogs, buns, ketchup, hot dog, buns. These are the set of the frequency item sets that are being purchased together. Hot dog, Now what is our first step? So we have to write down the what are the items we are having. So here we are having, I will write here items and the support count. Now what is a support count? Support count is the count of the number of items that exist in this, number of times an item exists in this particular database. Suppose, so here the items are hot dogs, buns, ketchup, Coke, chips. These are the item sets. So I'll write here, then we have to calculate minimum support and the confidence. So here the minimum support is minimum support is 2 and confidence. That means this confidence will be required later on. So minimum confidence is 50%. So what we have to do now, we have to count how many times a particular item exists in a database. So first is the hot dog. I'll write here hot dog, bun, ketchup, Coke and chips. Here this hot dog exists 4 times. 1, 2, 3, 4. So I'll write here 4. In the same way, then I will count for buns. 1, 2. So it exists for 2 times. Then in the same way, ketchup exists for 2 times. Coke exists for 3 times. And the chips exist for the 4 times. Now, next step is we have to discard the value that is having the minimum support count less than 2. Here, all the values are having the support count greater than 2 or equal to 2. But none of the values having the support count less than 2. So, we will not discard any value. Now, this was the first step. This is the first step. Now, here we have taken the item sets in a single pair. Now, we will take the single item sets. Now we will take these we will select these values in pairs. So this table we have to follow this table only. So next step is we will count for the values in pairs. Item sets and the support count. Now item sets can be here a hot dog. Like I will write here hot dog. I'll write some abbreviations here. Hot dog as H, buns as B, ketchup as K, Coke as C and chips as CH. So I'll write all these values in an abbreviated form. So next is the hot dog. For the hot dog exists for hot dog. Now we will take the pairs. We will take the pairs. Now hot dog, the pair can be, now we can form the pair of hot dog bun, hot dog ketchup, then hot dog Coke, hot dog chips. These can be the values of the, how the values can exist with the hot dog. So hot dog, buns, okay. Then hot dog can come with Coke, hot dog can come with ketchup, hot dog can come with chips. In the same way, we can select for the buns and ketchup. Then buns and Coke. Then buns and chips. Next is for the value ketchup. Ketchup and Coke. Ketchup and chips. and Coke and chips. So these are the values we can take. So next is what we have to do. We have to count how many times hot dogs H and B, that means hot dog and buns, are coming together in the above data set. So here hot dog and buns are coming 1, 2 times. So I'll write here 2. In the same way, hot dog and Coke, I will check for hot dog and Coke. Hot dog and Coke 1 and 2. It is also coming 2 times. Then hot dog and ketchup 1 time. Hot dog and chips 2 times. Buns and ketchup 1 time. Buns and Coke chips 0. Ketchup and chips are also not, ketchup and Coke are not also together. So we'll write here 1, 0 and 0. Ketchup and chips. Ketchup and Coke. Ketchup and Coke, they are also not together. Ketchup and chips. Ketchup and chips are coming for 1 time. And then the next is the Coke and the chips. Coke and the chips are also coming for 2 times. Oh no, not 2 times. It's for 3 times. Now, this is the table we got. Now, what is our next step? Now, we will again discard the values which are having the support count less than 2. So, here we will discard these values. This one, and this one. This one also. These are the values which are discarded because they are having the support count less than 2. So now again the refined table will look like items, support. Now H, B, hot dog and bun, hot dog and Coke, hot dog and chips, Coke and chips. Now hot dog and bun again we'll write here. So this is the refined data set we got. Now using this data set, now we will use, now this was for the second pair. Now we will form the pair of 3. Now using this table, only these values will be considered for forming the pairs. So here we can take hot dog, buns and Coke together. So it can be written like we can write it like this: hot dog, bun, Coke, hot dog, bun, chips. Okay. Then we can also take bun, Coke, hot dog, bun, chips, hot dog, Coke and chips. This can also be the pair. So these are the 3 pairs that we got. Now in the first table we will check how many times these values are coming into this database. So hot dog, buns and Coke, how many times these are being prepared, being purchased. So they are not purchased anytime, so I'll write here 0. Now next is for the value hot dog, bun and chips. How many times it is coming? Hot dog, buns, they are also coming 0. Next is hot dog, Coke and chips. Hot dog, Coke, chips, it is coming for the 2 times. So I'll write here 2. Again discarding the values having the support count less than 2. So these are the values that will be discarded. Now this is the data set we got here. We have got these sets, item sets: H, hot dog, Coke and the chips that that values that are being purchased together. So now we have to calculate the percentage confidence, or you can say support count. How many times, what are the association rules that are that can be generated using this data set. So in this, now we have formed the association rule for hot dog, Coke and the chips. These were for these values we have formed now we will form the association rules here. Now how the association rules will be formed? Now we will calculate the support for the values hot dog and Coke together, and we'll separate these chips. These can be the association rules. By using in the mathematics we use the association formula, so we will use these association formula here. So in the same way, the value will be support of here, the value of how it can be calculated, support of, now the value which is at the denominator, that is chips. Support of chips upon support of hot dog, Coke and chips will be taken together. So what is the meaning of support here? The values, how many times these values have existed in the data set, so we can form these sides. Now here chips has come 2 times, and in the same way the chips was for 2 times in that data set. This value is taken from the first value, the first table we have created. Like I'll write again the values. I'll write here again hot dog. I'll write for only hot dog, Coke and the chips. So hot dog, Coke and the chips have existed. Hot dog came for 4 times, Coke for 3 times, and the chips the chips was for the 4 times. And in the same way, hot dog, Coke and chips were for the 2 times. So what we have to do next? Support of chips. Now chips of support was 4. Upon how many times this data set has occurred? This occurred for 2 times, multiply by 100. So it will be I think the value will be like this. Support of here, the support of chips and the support of all these values together. Support of hot dog, Coke and the chips. All these will be taken together. Just a minute. How we can write it. Now support means how many times has items has existed in a data set. So support of hot dog, Coke and the chips upon support count of chips. So this is the first association rule. Now here hot dog, Coke and chips occurred for the 2 times and the chips has occurred for the 4 times. Then the confidence comes out to be 50%. In the same way, for the next value we can calculate for support for a hot dog and chips, and we will eliminate. We can say that we can purchase hot dog and chips together, but the Coke can be separated. So hot dog and chips, then Coke. Okay. Okay. Coke. Then in the same way, again we will write for support of H upon CH upon Coke upon support of Coke. This also comes out to be 4 upon 3 multiply 100. That is equal to 33.3%, approximately 33.3%. In the same way, we will calculate for other values also. Then we will select the association rule that is having the confidence value. That is, confidence means the percentage of the support count equal to or less than 50%. So here we can select this value 50%. So because it is having the value equal to 50%, if it is greater than 72% or 100%, we can also take those values. So this was all about the a priori algorithm. Now, next we will discuss about clustering. What is clustering? Now, my main motive for explaining the a priori algorithm was because the clustering involves a priori algorithm. So basically, what is a cluster? Cluster means grouping of the item sets together, having the same properties, which are having the same properties. Suppose, like, we can take an example. Suppose we are going to a shopping mall. We can say that whenever we are going for shopping, we can see that the section for the shirts, for the trousers, and for the winter wears or the formal wears, all the sections are different. So we can say they are grouped in a cluster. So that why we need to form clusters, so that we can divide the data set in a proper way. We can identify which type of data is this. So we can say the clustering is a technique of grouping the data items in according to their similarities, according to their similar properties. So we can say it is an unsupervised learning method. Why it is an unsupervised? Because we do not know what kind of data set is coming, what kind of association rules are being formed, what kind of data set we will combine. So we don't know anything about. We are not having knowing the output. We will work on the assumptions only. So this is an unsupervised learning method. So there are different types of clustering techniques. Basically how it works. Suppose this is a raw data. So now after by applying the clustering algorithms, we can refine these data sets. So this is the apple is categorized differently. This is a new fruit, next fruit, and all the fruits are categorized according to their properties. Next is the types of clustering. So types of clustering means, first is the partition clustering, density based clustering, distribution based clustering, hierarchical clustering. So what is partitioning clustering? Now partitioning clustering means that divide the data sets into two hierarchical groups. Means this type of clustering, basically it calculates the properties, it divides the data sets according to the properties by taking out the distance, how much distance is there in between the particular data set. So we can say it is a type of clustering that divides the data sets into non-hierarchical groups. It is known as centroid. Centroid means finding out the centermost point of a data set. So this is a K-means clustering algorithm, is one of the most efficiently used clustering algorithm here. Now next is in this type of data set, the data set is to divide into different groups. So groups we can say like here there are 4 groups of the data set. Here circles, triangles, squares, and circles. Circles of the different color. So we have divided the data sets into different groups. The cluster centered is created in such a way that the distance between the points of one cluster is minimum as compared to the another centroid. Suppose here, now what is the meaning of this? Here it is a centroid here. See, this is a centroid here. We will select only those points that are having the distance, the values distance having minimum distance across this centered point. So we will select only those values. So we can see here all the values are here having less distance in the centroid. They are not far. So we can say these are grouped in a one cluster, single cluster. In the same way, this is a centroid, and the points that are having minimum distance from this point, they will be selected. So next is the density based clustering algorithm. Now what is the meaning of density based? Density based clustering algorithm, it will select the data set, it will highly dense area. So means, what is the meaning of highly dense? How they are formed, as long it This method connects the highly dense areas into clusters, and arbitrarily shaped distributions are formed as long as the dense regions can be connected. So we can say these clusters are connected. How they are connected? According to the similarities, according to the similar properties, we will count what is the depth of the region, how closely these are linked, and what we do here, we will assume, we will calculate, we will write these, we will divide all these clusters in a single group, and the outer regions, what we do, these are called the outer boundary of the data set in the density base. Means how the regions that are being shaped having the similar properties, mostly similar properties. So this algorithm does it by identifying different clusters in the dataset and connects the areas of high densities into the clusters. Now next is the distribution maze. This distribution-based clustering model is a probability-based. Basically, we are working on the assumptions or the probability that this may be a part of that algorithm, may be a part of that cluster. So basically, what is a distribution model-based clustering? In the distribution model-based clustering method, the data is divided based on the probability of how a dataset belongs to a particular distribution. The grouping is done by assuming some distributions, commonly Gaussian distribution. Now, next is the hierarchical clustering. What is hierarchical clustering? Hierarchical clustering, we can say, it can be used as an alternative for partition clustering, as there is no requirement of pre-specifying the clusters. So in the partition clustering, we know how many clusters need to be formed. If we can say that like in the partition clustering, like K-means algorithm. Now here the K means how many groups can be formed. So we can say if there are 3 clusters formed, 3 groups are formed. So that is a 3 means algorithm. Now here in the hierarchical clustering method, we do not need to form the clusters. We do not need to know how many clusters can be formed. So in this technique, the data set is divided into clusters to create a tree-like structure. We form the hierarchical means there is a hierarchy. Like there is a root node, then after the sub-root node, then they are subdivided. So this is a tree-like structure. And this tree-like structure is a dendrogram. This is a dendrogram. We can say this is a tree-like structure of a particular observation. So then this hierarchical clustering can be of 2 types. First is the agglomerative approach, agglomerative hierarchical algorithm, and the next is the divisive approach, or we can say it is a bottom-up approach. Now, what is the meaning of agglomerative and the divisive approach? Now, they both are hierarchical clustering method. What they do, basically, they calculate, they divide the tree by in the agglomerative cluster, we form the bottom-up approach. Means we will start from the last node and then we form the tree. Now, this is an example of the agglomerative clustering algorithm. Now, in the divisive algorithm, what is divisive? Divisive means there is a root, like in the data structures we study tree or graph. That is a divisive approach. Means that it follows the top-down approach. Top to bottom we move. Here we move from the bottom, then the clusters are formed, and we are grouping the item sets according to the clusters. So that is an agglomerative, or you can say that is a dendrogram. Next is what are the applications of clustering algorithm? We can use the clustering in identification of the cancer cells. So basically, the clustering algorithms are widely used for identification of. Basically, we can find out which type of cell is there having cancer, can detect the cancer, is having the properties of the cancer. We can also detect in the medical field. We can use clustering. In search engines, basically, they also work on the clustering criteria. How they work, they identify the keywords. Search engines also work on the clustering technique. The search result appears based on the closest object to the search query. Next is the customer segmentation. Now, what is the meaning of customer segmentation? They divide the customers according to their preferences, according to their needs. Suppose a person who usually go like in our Facebook or in our Insta or social medias, like a person who is looking for the news only will get the updates on, will get more updates related to news. But a person who is studying, wants to study about some topic or some subject, they will get the news of the related to the notes or materials related to that unit only. So that is customer segmentation, the dividing the customers according to their preferences. In biology, it is used in the biology stream to classify the different types of plants and different species of plants and animals using the image recognition technique. In the land use, the clustering technique is used in identifying the area of similar lands. Now, similar lands used in the GI survey, this can be very useful to find for what purpose the particular land should be used. Suppose the land that is not fertile or the land that is not usable, we can use for it some other purposes, like we can build plots or anything. So basically, we can identify the land type according to by using the clustering algorithm. So before we move to the clustering algorithm, we will study about how this hierarchical clustering works. So suppose there is a data set 23, 42, 12, 10, 15, 14 and 9. We will study out how hierarchical clustering works. So these values, what we have to do here, we will write. We don't need to know how. We do not need to know how many. What will be the group of the cluster and all these. We don't need to know. So what we have to do here, we will write all these values here. 23 in the form of the table. In the top and in the bottom row, we will write all these values. 23, 42, 12, 10, 15. Suppose these are the values here. 23, 42, 12, 9, 7 and 42. These are the values. Now what we have to do? We will write all these values 23, 42, 12, 9, 7 and 44 here. Again 23, 42, 12, 9, 7. So this was all about the hierarchical clustering. All the clustering algorithm. So this is how this basically clustering works. Thank you very much.